Okay, now I'll take one more example. So on the DFA problems, so how to design a DFA. So take a problem. So design a DFA over sigma equal to a comma b such that number of a's and number of b's in a string both are even. So it means first of all write sigma. Sigma means what? Nothing but input symbols or input alphabets. Okay, that is what sigma. So what is the language? So first you write a language. Language equal to so epsilon. Okay, no, it means what is the meaning of epsilon? Nothing but a zero. Okay, zero number of a's, zero number of b's. That is what epsilon. So what is AA? Even number of a's. What is BB? Even number of b's. So you take one more string. What is the AB? So you see here, I am having a two a's, two b's. It means what? Even number of a's, even number of b's. You take BA. Again, this is what? This is the even number of b's, even number of a's. So again, I'm having a even number of a's, even number of b's. Okay, this is the language. Okay, you take any string. In that string, I'm having a even number of a's, even number of b's. So it means what? You take a length. For example, if I take BA, okay, you take like this BA. How many b's I am having? Okay, two b's. Okay, two b's. Even number of b's. How many a's I am having? Two a's. Okay, so length equal to how much? Length equal to 4. Okay, so 4 mod 2. So what is the remainder? Remainder equal to 0. That is what. So but you may have doubt. If I take a string AB, okay, this is not the string in the language. Why? Because you take a. How many a's I am having? Only one a, not even number of a's. How many b's I am having? Only one b, not even number of b's. So even though length equal to 2, okay, this is not the string in the language. Why? Because what they have given such that the number of a's and the number of b's in a string both are even. That is what. Okay, it means you take a, okay, separately they may even, okay, or combinedly they may even, but when you take like this is not the string in the language. Even though length equal to 2, so this is not the string in the language. So that is what. Okay, now see here, number of a's in a string equal to even, number of b's in a string equal to even. So that is what you have to, for that you have to draw the DFA. First you take a sigma. So here I am taking a like this example. Okay, so 0 1. Okay, so 0 1 1 0. Okay, 1 0 1 1. Okay, and then 0 0. Okay, it means what? Even number of a's. Okay, odd number of b's. Okay, odd number of a's, even number of b's. So odd number of a's, odd number of b's. Okay, so what is 0 0? Even number of a's, even number of b's. So I am taking a 4 states here. Okay, I am taking some convention. So in this way, 0 means even number, 1 means odd number, 1 means odd number, 0 means even number. Okay, so 1 means odd number, 1 means odd number. Okay, so like this you take. Okay, I am taking here AB. Okay, so AB. So what is the A? Even number of A's, odd number of B's. Odd number of A's, even number of B's. Odd number of A's, odd number of B's. That is what OO. Okay, so again what is 0 0? It means even number of A's, even number of B's. So like that I am taking the states. I am taking 4 states here. Okay, one is what? EE, OO, OE, and then EO. Okay, now you start. Okay, always you take the start state here. I am taking the states EE here. So when there is a epsilon in the language, the start state is the final state. Okay, now what is the convention? I have to form the edges EE on A, EE on B. I have to form the edges. Okay, now you write like this. Okay, so from even number of A's, okay, I have to form the edge on A. You write A here. So what is A? You write epsilon here. Okay, it means zero number of B's. Epsilon nothing but a zero number of B's. What is the meaning here? Odd number of A's, even number of B's. Okay, it means what? From the state EE, by seeing A, where I am going to the state OE. Okay, now form the edge. So you write the state OE. Okay, like that. Now, so EE on A, edge is over. Now again what? I have to form the edge EE on B right here. So EE on B. So you follow the convention AB. Okay, it means what? Epsilon is, okay, B. It means what? Zero number of A's, okay, zero number of A's, okay, odd number of B's. Okay, 1 second. E on B. I'm taking the 1 second. E on A, odd number of A's, even number of B's. OE. So when I take EE on B, okay, so here zero number of A's, okay, sorry, it is EO. Okay, it is even number of A's, odd number of B's. Then you take a some other state. Okay, you take some other state. Then like this I am taking on B. So what is the state name? State name is the EO. So odd number of A's, even number of B's. Even number of A's, odd number of B's. Okay, that is what. Now EE on A, there is a edges formed. So EE on B, there is a edges formed. Now what I have to do? I have to form the edges OE and then EO. Okay, now same procedure. So write OE. Okay, write OE. Now how I reach to the OE from the start state? Through the path A. First write the path A. Now I have to see OE on A. Write A here. Then what? Epsilon B's. It means zero number of B's. Even number of A's, even number of B's. It means what? OE on A, I am going to the state EE. Okay, like that. Okay. Now we have to form the edge OE on B. Okay. So OE on B. OE on B. First of all, how I reach to the OE from the start state E through the path A. First write the path A. Okay, then I have to see B. Write B here. So what is the B here? Odd number of A's, odd number of B's. Then what? We have to form the new state. State is the OO. Okay, so OE and B, I am going to the odd number of A's, odd number of B's. Here OO means not 0 0 here. It is odd number of A's, odd number of B's. Okay. Now see here, EE there is a edge is formed. EE B there is a edge is formed. So OE on A there is a edge. OE on B there is a edge. Now what is a pending? So I have to form the edges EO on A, EO on B. Okay, right here. So EO. What is EO? Even number of A's, odd number of B's. Now how I reach to the EO from the start state? It is E. What is the path? B. First write B here. Now when I see A, you write A here. So what is EO on A? Odd number of A's, odd number of B's. Okay, EO on A, I am going to the odd number of A's, odd number of B's, odd number of A's, odd number of B's. Next, so EO on A is over. Now what about EO on B? EO, first you see the path. How I reach to the EO from the start state? Through the path B. Write B first. Now what I have to see? I have to see B. Write B here. Now what is BB? So epsilon is, it means even number of A's, even number of B's. It means what? So EO on B, I am going to the, so B. That is what. Next. Now EO on A, the edge is over. EO on B, the edge is over. Okay. Now what is pending? So on this EE, OE, the edges are completed. So according to DFA rule, you have to form the edges on all sigma. Sigma equal to A comma B. You have to form the edges on all the states. Okay. Now OO is pending. Now take the path. So OO. So first write the path. How I reach to the OO from the start state? You take this or you take this. So EE on A. Next B. First write the path. I reach to the state OO through the path. You may take this also, no problem. Okay, I am taking this for my convenience. Why? Because I have taken the sequence AB. You take BA, you go like this. So EA on AB, this is the path. First write the path AB. Now I have to form the edge OO on here. Write A. What is this? Even number of A's, odd number of B's. It means what? OO on A. Where I am going? I am going to the EO. Okay, you form the edge. Now, so A is over. I have to form the edge on B. OO. First, what is the path? How I reach to the OO? Through the path A, B. So write AB first. Now what I have to see? I have to see the B. Now write B. Okay. Now write B. Then what is the state? So odd number of A's, even number of B's. It means what? So OO on B, I am going to the this one. Okay, na? So this is what? Okay, this is what DFA for the even number of A's and then even number of B's. If you want to check, okay, if you want to check, simply trace out. So for example, if I take the any string A, B, B, A. So this is the string in the language. Now where I have to start? Start from the EE. EE on A. EE on A, I am going to the OE. OE on B. OE on B, I am going to the OO. So OO on B, I am going to the OE. So OE on A, I am going to the EE. That is final state. Okay, the string is accepted. Also, I am reaching to the final state. Okay, this is the correct DFA. So in this way, you have to draw the DFA. So in the exam, what you write, you have to do everything like this. Along with that, you have to check whether the DFA is correct or not. Okay. Now take one more example. So it is same previous to the. It is extension to the previous one only. So design a DFA over sigma equal to A comma B, where number of A's divisible by 3, number of B's divisible by 3. Okay, it means what? First to take a sigma equal to a comma b. L equal to what? So what they are saying, you take any number, you take a's or b's, they are divisible by the 3. It means what? Multiples of 3, like 0, 3, 6, 9, 12, 15. So these are the numbers, okay, divisible by the 3. So I will get a remainder as a 0. That is what the question. So you take 3a's. So what is the 3a's? 3 mod 3. This is the length of the 3a's. What is the remainder? Remainder equal to 0. So this is the divisible by the 3. So length I am telling. So b, okay, 3b's. So we take this string ab, ab, ab. How many I am having? I am having the 3a's, 3b's. So 3 is divisible by the 3, 3b is divisible by the 3. So this is what? Okay. Now you you use same example and you have to extend like this. Okay, simple. So a, b, c, d, e, f, g, h, I. Okay, so I am taking the states like this. Okay, so I am extending same diagram to the this one. So what they are saying, when there is an epsilon, you write start state as the final state. This is the start state. Okay, 0 is, okay, 1a, 2a, okay, 3a. Okay, you do for same. Okay, simply you extend this diagram. Okay, simply I am extending this diagram to the next one, next level. So now again a, 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 next a, a, like this. Now what about b's? Okay, you do same as it is previous one. Okay, this is the diagram for the, so number of is divisible by 3, number of b is divisible by 3. You take any one example and trace it out. Okay, I'll take, you take a, b, 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 a, a. So how many b's I am having? I am having a 3 b's. How many a's I am having? I am having a 3 a's. Okay, now you trace. So where I have to go? I have to reach to the this final state. Okay, start from start state a. What is a on a? B. What is B on B? B on B, I am going to the E. What is E on B? I am going to the H. What is H on B? I am going to the B. So H on B, where I am going? I am going to the B. What is B on A? C. What is C on A? It is A. So A is the, it is final state. So what is what I told? The string is in the language. You have to reach to the final state. If string is in the, if string is not in the language, so I have to reach other than the final state. Okay, so that is what DFA for the, so number of A's divisible by 3, number of B's divisible by the 3. So this is the diagram. Okay, take one more example. Now here, so design a DFA over sigma equal to 0, 1. When interpreted as a binary number, it is divisible by 2. Okay, so first of all, what they have given? They have given sigma equal to 0, 1. Okay, now here when you divide any number by 2, I am getting a two types of reminders. So one is 0 remainder, second one is a 1 remainder. For example, when you divide 4 with 2, 2 to 4, it is remainder equal to 0. So when I take 5, so 2 to 4, it is remainder equal to how much? Remainder equal to, it is 1. You take for example 7. What will be the remainder? 2 3 is 6. So this is remainder. Okay, 1 is a remainder. Okay, now we'll see first. You write this like this. So for example, so q naught is the, it is 0 remainder class. What is a q1? Q1 is a 1 remainder class. First of all, okay, you take L equal to, so first of all, so you take 0. Okay, 0 is a what? 0 is a when you divide 0 by 2. Okay, so 0 by 2, what is the value? Nothing but a 0. Okay, so it means what? When you divide, okay, 0 mod 2. So always you make note, when you divide small number with a big number, small number is the answer, 0 is the answer. So then you make it as a final state. Okay, like this. Now, so it means what? Q0 on 0, I am going to the same state. Now Q0 on 1. Okay, so Q0 on 1. You write 1 here. You write 1 here. You use the code 8421 code. 8421. So 0 0 0 1. What is this? Which is equal to, when you write normal integer value, it is 1. So when you divide with 2, 1 mod 2. What is the remainder? Okay, remainder equal to 1. I told, when you divide small number with a big number, small number is the answer. It means what? I am getting a remainder. It means what? So Q0 on 1, I have to go to the Q1. Why? Because I am getting a remainder as a 1. Okay, so Q0 on 1, you go to the 1. Now, okay, so Q0 on 0, there is a, I formed the edge. Q0 on 1, I formed the edge. Now what about Q1? Okay, so Q1, so right here, so Q1. Now you take, how I reach to the Q1 from the start state? Through the path 1. First write 1 here. Okay, first write 1 here, and then one second. So now you see Q1 on 0. Okay, so Q1 on 0. Okay, so Q1 on 0, you write here. Okay, one second, I will check it. So 0, am I here? Then you write like this. Okay, 8 4 2 1. 1 minute. So I am writing 0 1. Sorry, you write 0 to the right of it. Okay, not to left of it. You write here. Okay, I'm doing one more time. So now I have to form the edge Q1 and 0. So first of all, how I reach to the Q1? through the path 1. Okay, then I have to form the edge q1 and 0. You write here. Okay, then you write this as for the code 8421. 8421. So 1 0, you add zeros zeros. So what is the value? Which is equal to 2. 2 mod 2, which is equal to, when you divide 2 with 2, what is the remainder? 0. It means what? So q1 and 0, I am going to 0 remainder class. That is what. Okay, so then you go like this. Okay, now so q1 and 0, I have formed the edge. What about q1 and 1? Same procedure. So q1 and 1. First you take the path. How I reach to the q1 from the start state? Through the path 1. 1. So this one you add to the right of it. Then what is the value? What is the value? So 8 4 2 1 1 1 0 0. What is the value? 2 plus 1 how much? Which is equal to 3. 3 mod 2. So when you divide 3 with 2, what is the remainder? 1 is the remainder. It means what? So q1 and 1, I am going to the 1 remainder class. It means what? So you take as a self loop. Okay, that is what. Okay, so this is the DFA for the given question. Now you take some example. For example, if I take I will take one example, 8 4 2 1. So I will take a even number. Okay, for divisible by 2, I will take 8 plus 4 12, 12 plus 2 14. Then what I will take? 1 1 1 0. Okay, so this is a binary number. What is the value? Value equal to how much? 8 plus 4, it is 12. 12 plus 2 14. Okay, so 14 mod 2. What is the remainder? Remainder equal to 2 sevens to 14, remainder equal to 0. It means what? So when I see this number, I have to go to the q naught. Okay, that is what. Okay, now you trace. Okay, so when you take this number, where I have to go? I have to go to the final state. Why? Because this is a string in the language. Then you write here 1 1 1 0. Then q naught on 1. I am going to the q1. So q1 on 1, I am in the same state. Again q1 on 1, I am in the same state. What is q1 on 0? I am going to the q0. What is the q0? Q0 is the final state. Okay, so the string is in the language, I am reaching to the final state. That is what. Okay, so that is what. In this way, how to draw the DFA for a given question. Now take one more example. Okay, so design a DFA over sigma equal to 0 comma 1 when interpreted as a binary number divisible by the 3. Okay, so here when you divide the any number with 3, I am getting a 3 reminders, 0 remainder, 1 remainder, and then 2 remainder. Okay, now I am taking some examples here. So I am taking 15, 3 5s are 15, remainder equal to 0. So 16, so 3 5s are 15, 16 minus 15, 1 is the remainder. Okay, I am taking 5, so 3 ones are 3, so 2 as a remainder. So that is what. So default L equal to what? So in the previous example, here I didn't write language, so there will be epsilon will be there. So I am taking this will be in the language. Okay, 1 1 1 0. So 1 0. Okay, and then 1 0 1 0. So and then 0 1 0 1 1 0. So these are the strings in the language. Okay, so starting I didn't know what is the strings in the language. So when you write like this, I'm able to know what is the strings in the language. Okay, so here also, okay, take this example. So I'm taking three shades. Okay, 0 reminder, 1 reminder, and then 2 reminder. Starting will be the, so always q naught and 0. Already I told. So 0 mod 3. What will be the remainder? 0 will be the remainder. So then what? So this is the start state. Also it is a fail state. Then q naught on 0. Now you have to form the edge q naught on 1. Okay, same procedure. So q naught on 1. You write 1 here. Okay, then you write the apply the code 8 4 2 1 1 0 0 0. What is the value? It is 1 1 mod 3. What is the remainder? Remainder equal to 1. It means what? Q naught and 1, I am going to the 1 remainder class, nothing but I am going to the Q1. Now Q naught and 0 there is a edge, Q naught and 1 there is a edge. Now I have to form the edge Q1 and Q2. So you take Q1, same procedure previous to the one. So how I reach to the Q1? You take the path, that is 1. Now Q1 and 0 1 0. Okay, so apply the code 8 4 2 1 0 0 1 0. So what is the value? Which is equal to 2. Then 2 mod 3. What will be the remainder? Remainder equal to 2. It means what? Q1 on 0, I am going to the Q2. Okay, so Q1 on 0, I am going to Q2. Now what about Q1 on 1? Q1, first of all, how I reach to the Q1? Take a path 1. So what I have to see now? I have to see the 1. You write 1 here. Okay, so apply the code 8 4 2 1 0 0 1 1. What is 2 plus 1? 3, which is equal to 3 mod 3, remainder equal to 0. It means what? Q1 on 1, I am going to the Q naught. Okay, it is Q naught. That is, so now Q naught and 0 there is a edge, Q naught and 1 there is a edge, Q1 and 0 there is a edge. What happened? So it is 1. Okay, it is 1, not 0, it is 1. So Q1 and 1, it is Q naught. Okay, so now I have to form the edge in Q2. Okay, apply same procedure. So then Q2. Okay, so now you write the path how I reach to the Q2 from the start state. So 1 0. Okay, write first path 1 0. So I have to see Q2 and 0, write 0 here. Apply the code 8 4 2 1 1 0 0 0. What is the value? 4, which is equal to 4 mod 3. So 3 ones are 3, 4 minus 3, remainder equal to 1. It means what? So Q2 on 0, I have to go to Q1. So Q2 on 0, I have to go to Q1. Okay, now what about Q2 on 1? Q2 on 1. So first write the path 1 0 you take 1, 8, 4, 2, 1. So what is 4 plus 1? Which is equal to 5. 5 mod 3. So 3 1s are 3, 2. It means what? So Q2 on 1, I am going to the Q2. Okay. So now you update the like this. So this is the DFA. Okay, this is now you see I have formed all the edges. So Q0 on 0, Q0 on 1, Q1 on 1, Q1 on 0, Q2 on 0, Q2 on 1. So all these states I have formed the edges. Now you take one example which is in the string. So 8, 4, 2, 1. I am taking a 12. 1. Why? Because 8 plus 4, 12. 12 mod 3, 0. So then 1, 1, 0, 0. What is 8 plus 4? Which is equal to 12 mod 3. Remainder equal to 0. It means what? So when I see this string, I have to go to the Q0. Now start. So 1, 1, 0, 0. Where I have to start from the Q0. So Q0 on 1, Q1. Q1 on 1, it is Q0. Q0 on 0, Q0. Q0 on 0, Q0. What is a Q0? It is a final state. The string is in the language. I am reaching to the final state. So now you write the language, okay, by seeing like this. First epsilon will be there again 1100. Okay, you use this code to write these strings in the language. Next one, what? You write 4 plus 2. It is 6. Okay, then what will be the string? 0 1 1 0. You write that in the language. So 0 1 1 0. So like this you update the language finally. So this is the DFA for the when the binary number divisible by 3. Okay. So in the next class we'll discuss about the NFA. Okay.